Okay, so in this video, we're going to go over this example where it says find a unit vector that is orthogonal to u and v. Right, so not just any vector, but a unit vector. All right, now we'll first start off by, well, let's find a vector that's orthogonal, right? Again, whenever you're asked to find an orthogonal vector, first thing you should always come to mind here is, finding the cross product, u cross v. Right, so I'll set up the determinant form here. I hat, j hat, and k hat, and our vector is -3, 5, -1, 0, 2, -2. Okay, and then we'll perform the first one again by we block out the first column, first row, and we're left with the submatrix 5, -1, 2, -2 times I hat minus, and then we'll have j, and then the submatrix by deleting the first row, second column, we get -3, -1, 0, -2, and that would be our j hat, and then plus, by eliminating the third column, first row, we get -3, 5, 0, 2, k hat. All right, and here we get -10, and then we'll wind up getting a +2, so we get -8 I hat. Here we'll get +6, and then a 0 or +6 with the minus out there, we get -6 j hat. And then lastly out here, it looks like we'll get a -6 k hat. Excuse me. Okay, so we'll call this vector W. All right, now we're not quite done yet. While this vector is orthogonal, just by the way we calculate it, it is orthogonal to u and v. All right, it's not necessarily, and it probably won't be a unit vector, right? So that's not a problem, right? Because we know from the previous chapter how to make something a unit vector. We can take W and then divide it by the magnitude of W. So, and again, to calculate the magnitude of W, that is going to be the square root of -8 squared plus -6 squared plus another -6 squared. And that becomes square root 64 plus 36 plus 36. All right, and whatever this is, what does this become? 36 and 36 is 72. So we got 72 plus 64. That is 136. Okay, and I wonder if any, does 4 go into this? Yeah, so we get, this is the same thing as 4 times 34, so we get 2 root 34, right, in simplest form. Okay. So we get our unit vector to be -8, -6, -6, all of that divided by the constant 2 root 34. Okay, and that is how we find a unit vector that is orthogonal to two other vectors, right? It will always start with the cross product.